next, we're going to move over from collections to actually helping you to build out your Flux alerts and notifications. And today, I'm really happy to let you know that Scott Anderson will be presenting. And Scott, are you ready?
Yeah, I'm here. Can you hear me? Perfect. Okay. Well, Chris, as she said, I am Scott Anderson. I am a technical writer here at InfluxData, the technical lead of the docs team, and I admittedly have an obsession with Flux. It's something that I'm really, really passionate about. Usually when we talk about Flux, we talk about kind of the beginning of the data pipeline, the ingest and the query. With Flux specifically, we mostly talk about the query, but I want to talk about the other end of the data pipeline, and that's the action that you can take on data after you process it. In this case, it's alerts and notifications. So my goals for today, first of all, is to demystify how to send Flux notifications. Up to this point, the process and methodologies for sending notifications in raw Flux has largely been hidden behind the InfluxDB UI. We've established a check and notification UI that lets you build this check and notification process, but we've kind of hidden the Flux code that gets generated by that process behind the UI. So not many people know how to actually send notifications in raw Flux. I'm going to walk you through all of that today. As I do that, I'm going to explain the different notification conventions that you can use to send notifications in Flux, and then I'm actually going to demonstrate those conventions. So first off, today, these external endpoints are natively built into Flux today. All of them are supported. In fact, since I've submitted my slides for this presentation, ServiceNow was shipped yesterday. So if you download or have access to the most recent version of Flux, it actually does support ServiceNow. And we have an open PR for pushover support that's just waiting for review and should be released as part of an upcoming Flux release. For anything that isn't natively built into Flux, you can use just regular HTTP calls to trigger an API call to some external service. So it's a really flexible system. So Flux is organized, the standard library is organized into packages. These are just logical groups of functions that perform a specific task and are all related in some way. So for notification-related packages, they all contain at least two functions. The first one is an endpoint function. And this is going to sound complicated. Bear with me. I'll explain what these do and how they work later in this presentation. But it's a function that outputs a function that iterates over all input rows and generates another function that sends a notification for each input row. I know, but there's a reason it's designed that way. The second thing that every notification contains is a notification function. It's a function that sends a single notification to an external service. So for example, in the Flux Slack package, you have the Slack endpoint function that iterates over rows and sends a message for each row. You also have the Slack message function, which is actually what sends the message to the Slack API. Inside of the PagerDuty package, you have PagerDuty endpoint, but you have PagerDuty, the PagerDuty.send event function that actually sends the event to the PagerDuty API. So when it comes to writing these notifications in raw Flux, there's really three different conventions you can use. The one-off convention, the map convention, the endpoint convention. So the simplest of these is the one-off convention. And this just uses, by the way, my presentation is almost all code. So if you don't like looking at code, I'm sorry, you're going to look a lot of it today. But the one-off convention is simply executing the notification function that sends a message to that external service. Each of these notification functions have parameters that are required to interact with that external API. So in this case, I'm going to use Slack as an example because it's a really commonly used tool. We're using it today. But to have access to the Slack package, I need to import the Slack package. And within the Slack package, I can then call the Slack.message function, and then the parameters that that function requires are one, a URL to the Slack API, a token to authenticate with the Slack API, a channel to post to, and then a message or the text to actually post, and then a color to associate with the message. These are all fields inside of the Slack API. So usually with the query data, the one-off convention doesn't do you a lot of good for sending like query data. You have to extract a scalar value somehow. So with this example, I have a last reported variable that's querying data from InfluxDB. It's finding the last reported value and extracting that as a scalar string. And then if you look in the call to the Slack message function inside of the text parameter, I'm using string interpolation to extract the value of the value column out of the last reported record that gets returned by that last reported value. So this is the one-off convention. It's a simple convention of just executing a function to send a single message to an external API. So the map convention builds on top of the one-off convention. So it consists of using map, and map has been talked about a little bit today, but essentially what map does is it iterates over every single input row, and it rebuilds the row record. So it rebuilds the row and the data that's in that row. Well, inside of a map call, you can actually execute another function. So with the map convention, you append a column to the row record, which is represented by R. Use the with operator to append the column. In this case, we're appending the sent column. And then we execute a send function, which sends that single message to the external API. And the response from that send function is the HTTP response code of the send request. So in practice, we're going to use Slack as an example again. I import the Slack package. I have a data variable that just represents some data that I've queried. I then pipe forward that data into map. I extend the row record with a sent column, and then I execute the Slack.message function with all of the necessary parameters to interact with the Slack API. The nice thing about this is because this is inside of the map function, you can actually use data specific to that row in generating all of the required API fields for executing that function. So in this case, I'm in my text parameter, I'm using column values from my input row to build the text string that actually gets sent to Slack. Now the endpoint convention is really similar to the map convention. And this uses the endpoint function that I described earlier that even when describing it, I feel a little bit dizzy. It gets confusing. So I'll describe it, and then I'll explain why it was done this way. So an endpoint function has parameters. It's usually the connection credentials required to connect to that external API. It then outputs another function that has a single mapFN parameter. In that mapFN parameter, you are returning, you're specifying a function that returns a record that maps all of the required fields for that external API. That then outputs another function that iterates over the tables, joins the record that gets generated from the mapFN, and then is able to send the message to the external API. From the outside, the map convention and the endpoint convention essentially work the same way. They both iterate over all the rows that are input into the operation and send a message for each row that gets input. So in practice, I'm going to use, again, Slack as an example. I have my data variable that just represents generic data. I'm going to call the Slack.endpoint function with its two required parameters are URL and token. Simple connection credentials required to interact with the Slack API. When I execute this function, it returns another function with a mapFN parameter, And the mapfn parameter for the Slack.endpoint function requires a channel, text, and color property. And just like we did in the map convention, we're using row data to populate text inside of the message that gets sent, but we could also populate the other fields or parameters that are sent to the external API. Now, the function with the mapfn parameter then outputs another function that iterates over all the rows. And to execute that function, I then include the open and close parentheses just after the mapfn function to execute the function that this outputs. So I know that this method it doesn't look user-friendly, and partly is because this method or this convention wasn't designed necessarily to be used by end users. This was specifically designed to be used when integrating notification endpoints inside of the InfluxDB user interface. So if you didn't know this, whenever you create a check and a notification through the InfluxDB UI, it's essentially a GUI that generates a Flux task on the back end and runs at regular intervals. When it comes to building these notification endpoints, this is very similar to what type of notification task would get built on the back end. So the InfluxDB monitoring middleware, it's built using the InfluxDB system buckets, specifically the monitoring bucket. There's a package designed to interact with InfluxDB and specifically the monitoring bucket. It's the monitor package. So in this case, this task that would get built, it's using the monitor package, which pulls in functions that interact with the InfluxDB monitoring middleware. It's using the InfluxDB secrets package, which loads sensitive secrets from the InfluxDB secret store, and then it's importing the Slack package. So I'm defining three different variables here. The notification data, which is generally populated by InfluxDB, but this appends data that InfluxDB uses when storing and then visualizing all the notifications that get sent. So when InfluxDB, when a notification gets triggered, it then stores that response, so you have notification logs that you can then review to see what notification activity took place. I then am providing a token. In this case, I'm pulling my Slack token from the InfluxDB secret store, and then I'm defining an endpoint variable using the Slack.endpoint function. So this convention was designed for integrations into the UI. So really, users would never necessarily be writing this type of task directly. This process was designed to be machine generated. So it's really easy to generate the variables inside of this convention and then call those variables. So at the very bottom, we're using the monitor.from function to pull statuses that have been evaluated and then stored in the InfluxDB monitoring bucket. And then we're using monitor.notify, and we pass our import variable to the endpoint parameter, which then triggers the iterative notification sending per input row, and it appends the notification data to each notification that gets sent. So that's why the endpoint convention exists. That's why it is what it is. That's how it was designed to be generated, to be used in these generated Flux tasks that are created from the InfluxDB UI. Now, so those are the three main conventions that you can use to send notifications in raw Flux. So what about I want to send a notification to a service that isn't natively built into the Flux standard library? This is where the HTTP post function really comes in handy. It has three parameters: a URL to send the post request to, headers to include with the post request, and then the data or the request body, which is a byte encoded string that gets sent with the request. So let's say I want to create, or I want to create a function that tweets. It creates a tweet through the Twitter API. The API that you create tweets through. Twitter calls them statuses, and it's pretty simple. It has a query string parameter that they refer to as a status, and then you have to authorize using OAuth credentials. So this is the syntax for creating a custom function. Here I'm defining a function called tweet. I'm saying that it has two parameters, a status and an OAuth. And then I'm using the curly braces are a block statement, which allows you to nest variables and then define a return object or a return value. So in this case, I want to define this nested URL or this nested variable. My API URL is the URL that is the API or the Twitter API URL. And then I'm going to return the response from the HTTP post request, which will be the HTTP response code for the request that gets sent. So in this request, just to build against the requirement, my slide went too fast. Okay, so perfect. So I have the URL parameter, and I'm using string interpolation to bring in the API URL. And I'm also using string interpolation to escape the input string, or I'm using the http.pathEscape function to escape my status that gets input. So it's taking this string and then just escaping it so it can be included in the URL as a query string parameter. And then using the headers parameter to pass my OAuth credentials. So I'm just gonna collapse my defined my custom function. I'm just gonna collapse that up. So to use that, I just call my function and I pass it the parameters. I pass it the status. I would include OAuth credentials, but it's a really long string and they're sensitive credentials. So I'm not gonna put it on a slide. But essentially what this does when I execute this function is it will create a tweet. So really simple integration, but tons of flexibility. Now, even though you're building these custom functions to interact with these external services, you can still use the 3 different conventions that we've talked about today. So with the map convention, you use that custom function inside of a map function. So again, I'm appending the sent column, and I'm just executing that tweet function using data from within the input rows. So in this case, I'm saying at whatever time the input row was, or whatever time is included in the input row, r.field was r.value, and it will tweet that. And I provide my OAuth credentials as well. Now for the endpoint convention, there actually is an HTTP endpoint function that you can then define your custom function to work with. So what it would look like is this, and I know this is probably pretty small for people. So we might want to zoom in if we can. If not, that's fine. But essentially, you're importing the HTTP package to get access to the HTTP endpoint or function. I'm defining all the variables required to both connect to Twitter, authenticate with Twitter, and append notification data, and then defining an endpoint variable, and then using monitor.from and monitor.notify to iterate over my data, send notifications as tweets, and then store that data about those notifications that were sent inside of the monitoring bucket. So now time for a quick demo. Okay, I'm going to give you a quick demo of the 3 different notification conventions you can use to send notifications with Flux. I've set up 3 different notebooks inside of InfluxDB Cloud, each to demonstrate one of the notification conventions. I've also set up a Discord server to send these messages to. This first notebook demonstrates the one-off convention. I'm importing the Discord package. I'm also using the InfluxDB secrets package to hide any sensitive credentials and pull those from the InfluxDB secrets store. Because InfluxDB notebooks require the output of a stream of tables, I'm using the array.from function to actually build a stream of tables using the output of that discord.send function. So when I click run, I should see a notification inside of Discord. Looks like it just came through. Switch over and yep, here is the message that was sent by Flux using the discord.send function. Let me switch tabs real quick. So this next notebook demonstrates the map convention. I'm using the sample data package, which provides really basic sample data sets. And it's built into Flux, so it's really easy to load. This graph just graphs the sample data that gets returned. And with any alert, you want to define some kind of threshold to alert on. So in this case, I only want rows with values above 18. So when I filter the data, I can then see that these are the rows that it'll return. And I'm just going to switch my visualization here, and you can actually see the values in those rows. Now, to send the actual notification, with the map convention, you use the map function to iterate over all the input rows. So I'm using map, and then I'm appending a value to each input row called sent. And to get the value of that column, I'm executing the discord.send function, which sends the message to Discord using data from the input row. So if I click run, I should get 2 messages in Discord, one for each row that gets input into the map function. So I saw 2 notifications come in. I'll switch over, and there they are, each of them using data from the input rows. Now let me switch over to my Endpoint Convention notebook. Again, this is using the sample data package. In fact, it's using all of the same sample data and filtering as the map notebook. But where it differs is how it sends the notification. This is using the Discord endpoint function. I provide the connection credentials required by the endpoint function, and this outputs another function with a map fn parameter, where I then use row data to map the value of the content parameter. So this is the message that actually gets sent to Discord. So when I click run, I should get 2 messages sent to Discord. Looks like they just came in, and there they are, 2 more messages using the endpoint notification convention. All right. I know this has probably been a fire hose of information in about 20 minutes. So I hear there may be 1 or 2 questions. Let's hear them. So question number 1, converting string values into integers in InfluxDB, totally possible. There are type conversion functions or typecasting functions just built into Flux. So as long as it's a numeric string, you can convert it into any numeric value, integers, unsigned integers, and floats. The specific function to convert a string into an integer or any data type that can be converted into an integer is the int function. If you just search int function on the docs, it should take you right to it. That appears to be the only question. Oh, they're coming. Okay. Let's see, any other questions for me? Okay. In InfluxDB 2.0, how to merge and sum 2 separate bucket streams into one with Flux. Great question, and it really depends on how you want to merge these streams. There's really 2 ways to do this. You can use a join, which is an inner join that joins rows based on 1 or more column values, or you can use a union, which just takes 2 different streams of tables and merges them into a single stream of tables. So the benefit of I guess there's different use cases for each of these. So the time you want to use a join is when you want to associate specific column data or specific column values based on 1 or 2 or 3 column values. So for example, if you want to take data from a relational data store like Postgres or whatever. For example, if you're storing machine data in Postgres, and you want to join that machine data with the sensor data that's being collected from that machine and just enrich that data, you would use join, and join based on the sensor ID or the machine ID, the timestamp, etc. With union, you can query two separate buckets and union those streams together, and then manipulate the streams as they're union together. So just different use cases. The next question: alerts versus notifications. Describe. That's a great question. In my mind, most of the time they're synonymous, but I understand that there can be subtle differences. Alerts, there's obviously some urgency inherent in the word alert, but usually with an alert, you define some type of threshold. You're filtering your data based on values that exist in the data. And anything that's left behind after that filter, you want to alert on. You want to send a notification. So that notification is the API call that actually gets sent out, whether that's creating an event in PagerDuty or tweeting a message or posting a message in Slack. That notification, what that actually does can change, but the alert generated from a defined threshold is what triggers that notification. So I guess that would be the relationship. Is alerts are defined by a threshold that could be a dead man as well. So a machine not reporting anything would trigger an alert, which then sends a notification. But this, we might be splitting hairs when we're trying to define the true difference. Again, in my mind, a lot of the time they're synonymous, but I think alerts has a little bit more urgency to it. Next question: how to test with sample data in an InfluxDB query. So we have multiple sample data sets available built into Flux. There is the InfluxData InfluxDB sample package, which provides sample data sets that you would that are formatted in a way that if you were to use them or if you were to query them, they would return data as they would if they were queried directly from InfluxDB. So they're structured with a measurement, they're structured with tags, they're structured with field keys, they're structured as data would be inside of InfluxDB. We also have the sample data package, which just provides these really bare bones sample data sets with specific value types. So there's a float function that returns sample data with float values, the sample data.int, which returns sample data with integer values, Boolean, etc. But they're just really basic sample data sets with two tables. They don't have measurements. They don't have field keys. They're just really basic generic data sets that aren't specific to InfluxDB. So those are the different ways you can test data or sample data with an InfluxDB query. Now you can query them directly from S3, which is where a lot of our sample data sets are stored. There's annotated CSV data sets that are out there that you can query. They're all over the place, but there's so many different ways to get them in to a Flux query and then join or merge that data with data queried from InfluxDB. So there's a lot of different ways to use sample data. Next question: the average of two sums in a Flux query in InfluxDB. So the average of two sums, it depends on how you're calculating those sums. And I mean, we're getting into some pretty use case specific flows here, but let's go there. If you were to sum or use the sum function, the way that these aggregate functions work inside of Flux, and I'm going to back up a little bit. We're going to go back to some important concepts to understand about Flux. So Flux returns a stream of tables, and the stream of tables consists of multiple tables, and each table is a collection of columns with associated rows. So if you're coming from relational SQL land, the structure of results might be somewhat foreign to you, where it can actually include multiple tables. The reason that's important is when you execute an aggregate function, that aggregate function works on a table. It doesn't work on the entire stream of tables. So when you have multiple tables inside of your input data, the aggregate function is going to return the aggregate value of each individual table. So let's say I have two sums, or I have two tables in my stream of tables, and I execute sum. It's going to return the sum of those two tables still in two separate tables. I can then ungroup those, and then with the ungrouped data, I just run it through the mean function, and it'll give me the average of those two sums. I don't know if that is exactly the use case you were looking at. If not, feel free to ping me in Slack, which, shameless plug, I will be available on Slack tomorrow from 9 a.m. to 11 a.m. Pacific to answer any questions that you have. And it looks like I am out of time. Yeah, there's still some good questions in there. We might have to just get to them in Slack.
All right. Yes, there are some pretty good questions in there. And so yeah, I think what we'll do is we will post those questions in the Slack channel so we can get them answered. In fact, we'll post them in the Flux Slack channel, so the people that are not hanging out with us today can also take advantage of it. But those questions, Scott, look pretty intense, so also gives you a moment to be able to think about the answers. So